Welcome to the MS SQL Tips webcast, SQL Clustering 101, Building Clusters to Protect SQL Server and Cloud Configurations, sponsored by SIOS Technology. I'm Greg Robidou, co-founder of MS SQL Tips and today's webcast host. Joining me today is Dave Bermingham, who will discuss what you need to know about clustering SQL Server in the cloud. Before we get started, if you have questions, you can submit them at any time during the webcast. Enter your questions in the question area in your presentation controls. We'll try to answer as many questions as possible during today's webcast. If you have any technical issues with sound or screen quality during the webcast, use the questionnaire to let us know as well. If you're not already a member of the MS SQL Tips community, we invite you to join. You go to www.mssqltips.com and sign up for our newsletter, read tips, download white papers, watch videos, and post your SQL Server questions to be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with the links. So at this time, I'm going to turn things over to Dave, and he can begin the presentation.
Thanks, Greg. As Greg mentioned, this is a second webcast in a series of SQL Clustering 101, and this webcast is going to feature on building clusters in the cloud. So before we begin, just a little background on myself. I've been a Microsoft Cluster MVP for the past 5 years, and I blog all about clustering on clusteringformeremortals.com. Recently, I've had a couple of my blog posts picked up by Microsoft Press. Specifically, my last one was on Azure high availability configurations for SQL Server. So you can find articles there as well as the Clustering for Mere Mortals. I'm employed with SIOS Technology for coming up on 11 years now. I'm a senior technical evangelist there, also do some product management, but exclusively focused on helping customers deploy high availability and disaster recovery solutions for Windows servers. I've been doing that for the past 11 years. You can follow me on Twitter at Dave Berm and SIOS Technology at SIOS Tech. So today's agenda, first we're going to just do a little background, make sure we're all level set on what the cloud is and what we're talking about when we say high availability in the cloud. And then we're going to talk a little bit about, well, why do we need high availability in the cloud? Doesn't the cloud providers automatically give you high availability? So we'll address that topic a little bit. And then we'll look at some of the options for SQL Server high availability in cloud deployments. And then we'll take a closer look at a technology I like to call Sandless failover clusters for high availability in the cloud as well as on-premise. So defining the cloud, I think the standard definition really comes out of the National Institute of Standards and Technology. And there's a couple of characteristics about the cloud. One is that it's an on-demand self-service, meaning that you should be able to go to the service provider with your credit card in hand through their web portal and sign up without needing any contracts or human intervention with that service provider. So it should be instantaneous on-demand service. It should have broad network access. So you should be able to connect to your cloud service through standard mechanisms such as your mobile phones, your tablets, laptops, and workstations just across the public network. Another characteristic of the cloud is resource pooling, meaning that the cloud provider has a pool of resources which is shared amongst multiple consumers. So it's a multi-tenant model. And this gives the provider some ability to reduce costs and also to allow them to provide rapid elasticity, meaning that as your demands increase for your cloud service, the cloud provider should be able to give you additional resources on demand, either automatically or with minimal configuration changes. And that service should be measured. So the cloud should be able to give you a report on an on-demand basis in terms of how much resources you're consuming, whether it's storage, processing, bandwidth, or the number of user accounts you have signed up for that service. And you should be able to monitor and control that, again, on demand. So that's 5 essential characteristics of the cloud. how is the what are the service models? So the cloud really comes in a lot of different flavors, and people think about the cloud in different ways depending upon how they're currently consuming cloud services. First is software as a service, and I think this has been around for quite some time. Not always maybe being called software as a service, but if you think about um, Google Apps, if you have done, signed up for Google Apps or using Google Enterprise um, Gmail, that's software as a service. Salesforce, if you're in sales, Salesforce is a service that you can sign up for to help to manage that sales process. And higher education uses a service called Blackboard, which helps them deliver education to the classroom, the online models. Then there's the platform as a service, which essentially the cloud provider delivers a computing platform that you can then develop your applications on top of. So they might give you a programming language and a database tier and a web tier, and you can then build on top of that. The biggest difference between the platform as a service and what we're going to talk about next is that the cloud provider manages the underlying architecture, so the storage and the compute. You do not have to manage the networking. All that is taken care of for you under the covers, and you just build your application on top of the services that they're providing. So Force.com, you notice there's some cross-pollination here. So Salesforce is this great software as a service, but they have taken that platform that they've developed and have offered it as something called Force.com. You can develop your own service on top of that platform as a service. SQL Azure, so Microsoft Azure services originally came out with the SQL Azure service, and so it was hosted SQL that you could build your SQL Server applications on top of, and you didn't have to manage the underlying database engine. Microsoft was doing all of that for you and allowing you to leverage your knowledge of SQL Server to build applications on top of that. And the same with Amazon has this RDS, or Relational Database Services, similar to SQL Azure. They're hosting the database tier and allowing you to build on top of that. You don't have to manage the underlying database. And then finally, infrastructure as a service. And once again, you see there's some cross-platform support here. We have the two big ones, I would say, is the Microsoft Azure service. So in addition to the Azure SQL services, the Microsoft Azure provides just the infrastructure for you to then go ahead and build your application on top of that. And in the Amazon world, that's called EC2. So essentially, the provider is providing a hypervisor, whether that's Zen, KVM, VMware, Hyper-V, VirtualBox, any of those hypervisors. And they're giving you the ability to provision virtual machines as guests, and they're pooling all that so they can they have large numbers of physical servers they can share amongst multiple customers. And they may also provide, in addition to just basic virtual machines, they might provide a library of pre-configured virtual machines that have applications already installed and configured that you can plug into your environment and use as needed. In addition to the virtual machines, they provide the storage. So they have raw block storage or file or object storage devices to store your information. And then there's other things such as firewalls, load balancers, and all your IP address is going to be able to be configured through infrastructure as a service. And then connecting your service, if you want to, we're going to talk about next, extending your on-prem to the cloud. They also have support for providing VPN access into the cloud and virtual local area networks within the cloud. And then finally, the deployment models. When you think of the cloud, there's the public cloud, which again, that's accessible to anyone in the general public, usually through a web portal. You go and you can sign up. So anyone can sign up for Google Apps today, or anyone can go to Amazon and sign up for an Amazon Web Services account and provision virtual machines. And that's the public cloud. And then the private cloud is taking the same idea of this on-demand, pay-as-you-go, highly scalable infrastructure, but making it local to just your company or your data center, so that you can service just your local customers, and that's called the private cloud. So that's the on-premise cloud solution. And then there's the idea of a hybrid cloud, which allows you to use a combination of public and private. So you might have your local area network have some cloud services, but you might extend that and take advantage of the public cloud services for additional workloads or for disaster recovery. There's some other smaller cloud models, one being community cloud, which is simply the public cloud, but geared towards a smaller subset of the public. So like professional services might have a portal for educational, for teachers, or there may be a portal for lawyers and whatnot. So it's just kind of the concept of a public cloud that is really just limited to a certain subset of the public. So what are we going to focus on today? When we look at the service model, we're really going to look at the infrastructure as a service. We're not going to talk about the software as a service, platform as a service, because we really have no impact. We can't have any impact on the availability of those services. We're relying on the cloud service provider to ensure that your Salesforce is going to be online and your Google Apps is going to be online. There's nothing that we can do on our end to really extend the availability of that. But when we look at the infrastructure as a service, the service provider might give us some tools to help us in our quest for high availability, but it's really upon us to put those tools together to make sure that our applications are going to be highly available. And that's relevant for any deployment model. So whether it's private cloud, public cloud, hybrid cloud, anything we talk about today is going to be relevant for any of those deployment models. So why are we concerned about high availability in the cloud? If we look at this quote here from the Gartner Newsroom, we see that people are moving rapidly to the cloud for their business critical applications, and they're saying by 2016 that nearly half the large enterprises are going to have their business critical applications deployed by the end of 2017. And just because you move your applications from on-premise to the cloud does not mean that you can forget about high availability. As we discussed, you need to plan for high availability, especially if you are using infrastructure as a service. And so before we move on, I just want to get a feel for who is actually moving to the cloud. So the first question, if you could go ahead and answer this, is do you currently have any business critical applications in the cloud? Let's take just a moment here and put that poll up.
All right, so far we have about 60% people voted. We'll just give another 15, 20 seconds, and let's see how many more people we get in here. All right, let me close this poll. And then we share the results. So 71% said no and 29% said yes.
Okay, great. So that leads us to our next question. As Gartner was saying, they are anticipating a large percentage of customers moving to the cloud. So not having an application in the cloud today, who is planning on moving any business critical applications to the cloud by the end of 2016? We take just a second to answer that question.
It'll just take another 10 or 15 seconds and get some more people to vote. All right, let me close this and share the results. So we have 63% say yes and 38% said no.
All right. Well, that kind of lines up almost precisely with what Gartner is predicting there, with more than half the enterprises moving business-critical applications to the cloud. That's great information to have. So when you're moving to the cloud, we know, if you've been reading the news or keeping an eye on things, that downtime can still happen in the cloud. Just because you've moved your workload to the cloud does not mean that you have to stop worrying about downtime. And here's one person's take on it, Josh Whitaker from ZDNet, saying basically you're going to get about 3 nines from the cloud. And I know 3 nines for most business-critical workloads is not enough. And you need better availability, more like 4 or 5 nines. The 9 hours of downtime per year is not does not meet your service level agreements. And if you just look for 2014, I mean, we can go through this list, but Dropbox, starting in January, the Samsung and Adobe, the Internet data center outage, and Joint and Microsoft Link Online and Exchange, Verizon, all these. This is just in 2014. These are some of the major cloud outages that have happened just so far this year. So we know that the cloud is not the end-all, be-all. You need to address your availability beyond just simply moving your applications to the cloud. So when we look at the cloud, again, they give us some tools and they give us some ability for high availability. If we look at like the web tier or the application tier, just like a traditional data center, you can deploy multiple nodes in those tiers and do things like load balancing in front of those tiers to give you not only spread the load across multiple nodes, but also gives you a level of availability. Should you lose a node or two, the other nodes will continue to function. And even in the most clouds give you a couple options in terms of different geographic locations. So when we talk about Amazon EC2, they have a terminology of availability zone. So an availability zone is still within the same geographic region, but they're separate entities, so that they do not share the same power, same networking, and so there's there's independence between the different availability zones. And when we've seen outages in EC2, generally they are only affecting a single availability zone. So by deploying multiple VMs in different availability zones gives you a level of availability. So for your web tier and your application tier, that works just fine. But when you come to the data tier, and specifically if we're looking at SQL Server, simply putting SQL Server, a couple SQL servers in different availability zones does not address availability. There's no way to load balance SQL Server, no way to do that without doing some configuration behind the scenes. So you have to address the availability of your SQL Server in a different way. So what are your options today? So not going into the log shipping and some of the older technologies, database mirroring and so forth, but really there's 2 choices that are the current recommended solutions. And one is, if you're on the SQL Server 2012 Enterprise Edition or 2014 Enterprise Edition, you can look at the always-on availability group technology, which gives you high availability without shared storage. And again, I think of it as kind of an evolution of database mirroring and as an alternative to the traditional always-on failover cluster, which people have been doing for many years. So there's that solution. Then there's the Sandless failover cluster, which is a traditional failover cluster. So we're clustering the entire SQL Server instance, and that is supported in SQL Server Standard and Enterprise Edition. And the replication is actually done by software that does keeps the data in sync between the different nodes and integrates with failover clustering. And it's because you can use Standard Edition, there's generally a good cost savings there as well. So what is a Sandless cluster? A little bit more detail here. You see a Sandless clustering is using real-time block-level replication to synchronize local storage between the primary and secondary nodes. And it does not require a SAN, so we eliminate the SAN as a single point of failure, but also open up the possibilities of clustering SQL Server nodes across different geographic locations, or in the case of Amazon, between different availability zones. Azure has a terminology of fault domains, which is essentially their version of availability zones, so you can cluster between those. And Sandless clustering applies for cloud is really the only game in the book. There is no shared storage, so you can't build a traditional cluster. But even in traditional data centers, on physical servers or virtual environments, you can do Sandless clustering, and it gives you some performance benefits when you look at using local storage like PCIe flash-based storage. You have some really great options out there for low latency, high-speed storage, but because it's not shared, you can't build a traditional cluster. So the Sandless cluster is going to step in and fill those gaps in the cloud as well as your local area network. So when you're considering, always-on availability groups versus Sandless clustering, you have to look at some of the limitations besides, needing the enterprise edition of SQL Server. There are some other limitations of always-on availability groups. So if you're doing any sort of distributed transactions, you can't use always-on. There is an upper limit to the number of databases with always-on. So as you add more databases or more availability groups, more worker threads are consumed. So you get to a point where your CPU utilization is being exhausted. So there's an upper limit to the databases. And the availability groups does not protect your system databases. So if you're trying to keep your agent jobs in sync or your SQL loglines in sync, you're not going to be able to do that automatically with the availability groups. You have to manage that separately. And because it is a database by database configuration, every time you add databases, you have to configure that in an availability group. So the administration is going to be a lot more difficult to maintain moving forward. And it does only support 2 nodes in the failover configuration, so you're limited to just a 2-node failover there as well. And if there's any data that resides outside the database, it really does not address that solution. Whereas the Sandless cluster and all those features are fully supported. So again, this is a Sandless cluster is really, think of it the same as a traditional shared storage failover cluster. So we're clustering the entire SQL Server instance. So any new database you add is automatically protected. All your system databases are protected. You can add an unlimited number of databases. With the block level replication, we're really not aware of how many databases you actually have. It's just blocks on the disk, so you can scale very well, and it supports multiple nodes in the cluster. And you can also build replicate other data. So if you have file shares you want to replicate, or anything that resides outside the database, again, because of block level replication, will replicate any of that data. So how is high availability in a cloud different than on-premise? Of course, the shared storage, once you move to the cloud, there is no concept of shared storage. So instead, you're going to have to look at doing some sort of replication between the local storage and the different servers. And the Sandless clusters will do that for you automatically. We'll synchronize the storage and integrate with failover clustering, so that failover clustering sees that storage as it looks like a shared disk, so that failover will happen automatically with no user intervention. So we mentioned about failing between different availability zones is the terminology for Amazon or fault domains in Azure. But you can also stretch much further. So you can, if you configure the networking between different geographic regions in your cloud, you can replicate and fail across from the east to the west coast. Also from on-premise to off-premise. So what I see people doing, using the cloud, provisioning a node in the cloud and using the cloud as their disaster recovery site. And using the cloud, it really allows them to have a very cost-effective and flexible disaster recovery solution without having to build out an entire VR site and maintain that. So it's a very attractive solution for disaster recovery. So how do you get into this hybrid cloud? It's depending upon the cloud provider, it's pretty easy to extend your on-premise network into the cloud via either a VPN or some sort of direct connection to the cloud. So that's the first step, is to create that network so that your VLAN or virtual LAN kind of spans from the cloud to on-premise. And then you're going to, of course, extend your Active Directory to the cloud. So you're going to start with a domain controller in the cloud so that you have disaster recovery for your domain controller. And then you're going to extend to the cloud. So you have to do the data replication. You have to get your data from on-prem off into the cloud. And if you could do that with just the data, or you can also integrate with failover clustering so that the recovery into the cloud is going to be more of a push button or automatic solution for a very good, not only recovery point objective, because the replication is going to be real time, but also recovery time objective. You're going to be able to bring things back up and running relatively very quickly. Typical hybrid cloud deployments that we're seeing, again, people might start and they have their business critical applications. If it's business critical, generally there's some sort of availability already on that application. So they might have a 2-node failover cluster like pictured here, and they can simply extend that 2-node shared storage failover cluster to the cloud with the replication and the cluster integration from the Sandless cluster software to have a very robust disaster recovery solution. Or for new applications, they might be looking to eliminate reliance on the SAN completely, and so they can have local failover in the Sandless cluster configuration between 2 or more nodes, and then just add a 3rd node in the cloud as a disaster recovery node, and that gives them the local HA as well as disaster recovery on both sides of the data center. So jumping into some case studies of some customers I've been involved with is Gulliver International. They're a company that deals with pre-owned cars. They have 420 locations, and they are rapidly expanding. And so what they're doing is they have some mission-critical SQL Server databases that are used to run their business, so reservations and all their operations. And they have a mandate of cloud-first infrastructure. So they're all in on cloud. They have bet the business on cloud. So it's always cloud-first infrastructure, and this is going to allow them to handle that rapid growth that they're anticipating. But however, they want to continue to have the high availability that they're used to in their physical data center with the Windows Server failover clustering. So they're very familiar with SQL Server clusters, and they want to stick with that solution. So they needed an affordable, easy way to deploy failover clusters in the cloud, and their cloud provider that they chose was the AWS, so Amazon Web Services, EC2, Infrastructure as a Service Cloud. However, there is no shared storage, which is generally required for a SQL Server failover cluster. So what they did is they looked to SIOS, and they came upon a solution called DataKeeper Cluster Edition, which would allow them to still build a traditional failover cluster, but using the Sandless replication technology to keep the data in sync between the different availability zones. And that gave them the high availability that they were looking for in the cloud with a very cost-effective solution. The next customer, the results were, it was easy from the time that they did the evaluation to the deployment. It was very fast and easy for them because the solution is based upon the technology that they were used to, the SQL Server failover clustering. and it didn't mean, so they didn't have to retrain their systems administrators. It's very simple and understandable solution for them to adopt. The next company is an unnamed online gaming company, a casino, and again, they were using SQL Server, and they had their Tier 1 applications in the SQL Server in the Amazon environment. But they were looking for additional high availability and disaster recovery configurations. Obviously, if their systems are offline, people are not gambling, they're not making money. So it's very critical for them to keep their applications online at all time. So they took their time and evaluated a few different options. So they looked at doing just some replication only, just to make sure that their data was recoverable in the event of a disaster. Then they looked at using Windows Server Failover clustering with DataKeeper Cluster Edition, similar to what we saw with Failover Travel. One of the wrinkles there is SQL Server itself has some limitations when you go between Standard and Enterprise Edition. And one of those limitations is that SQL Server Standard Edition, although it will support a 2-node cluster, it does not support cross-subnet failover. And if you're looking to fail between 2 different availability zones in Amazon, those availability zones are going to be in different subnets. So failing between availability zones in Amazon is going to require the SQL Server Enterprise Edition if you want to use Windows Server Failover clustering. But what they actually wound up doing is choosing a cluster alternative product called the SIOS Protection Suite, which essentially mimics the functionality of Windows Server Failover clustering, but does not have the same limitations. So they were able to build a failover cluster between 2 different availability zones and 2 different subnets, but they were able to stick with the SQL Server Standard Edition, which generally would not allow cross-subnet failover. And that gave them the ability to build that cluster and save a significant amount of money in software costs. So the SQL Server Standard versus Enterprise Edition, as you probably know, there's quite a cost difference. So they were able to get the functionality that they needed with much less of an investment. So to summarize what we've talked about today, SQL Server and cloud deployments need HADR protection. It's not going to be highly available by default. You can use always-on availability groups, certainly. You can check that out if it meets your needs. That is a good solution for certain customers. However, if you look a little bit deeper, you can see that Sandless clusters can give you even additional advantages, such as mixing physical, virtual, high-performance storage clusters, so you're not limited to that 2-node configuration. You can extend your configurations. And you can use Standard Edition without requiring the additional cost of the Enterprise Edition license. So Standard Edition, high availability, and disaster recovery into the cloud is again going to give you additional cost savings. It's very easy, seamless deployment, again, because it's built upon Windows Server Failover clustering. You're going to be able to be up and running and not have to learn a whole new tool. So with that, let's go ahead and see what kind of questions we have coming in. If you want to learn more about SIOS and how we can help you with your cloud deployments, you see our contact information here, the email address, phone number, Twitter. So definitely reach out to us, and we'd be glad to get on the phone and discuss any questions you might have. So let's go ahead, and I'm going to check the questions. Greg, maybe
yeah, actually, yep, I'll kind of rattle them off to you. And while we're going through questions, if anybody has questions related to clustering or what Dave just spoke about, feel free to put them in the question area, and we'll kind of go through those as we have time. So the first question is related to versions of SQL Server. Does this work with any particular versions, or is it released 2012, 2014?
Yeah, it really, Sandless clustering technology from SIOS, it's been around since 2008 was introduced. And so back in 2008, I was just Windows Server 2008. So at that time, it was like SQL Server 2005 was still widely in use. So we have customers running way back, I guess the earliest version is SQL 2005 Standard Edition. And as a kind of a general rule of thumb, we follow Microsoft's support policy. So if Microsoft supports a version of SQL or a version of Windows, then we continue to support that as well.
Okay. Actually, do you mind just hiding your controls? Thanks.
Sure.
Awesome. All right. The next question is related to the size of databases. Is there any particular size? Can this be, a gig, 10 gigs, 100 gigs? Is there?
Yeah, no, good question. So the underlying replication technology is block level volume replication. So one of the great things about doing block level replication is that it scales incredibly well. So it runs below the file system, and so we really don't care about how big the database is or how many databases there are. It's just blocks on the disk. So there is no limitation. We have customers with tens of terabytes of data we can replicate just fine.
Okay. The next question is related to the terminology Sandless. Somebody just wants to know, so where is the actual data stored? Is it still stored in the SAN? Is it local? Can you kind of explain that?
Yeah, so if we're talking about Amazon EC2, what we're going to do is we're going to use EBS and elastic block storage, and we're going to attach additional volumes to each virtual machine. So each virtual machine is going to have its own independent volume that is attached to it, or multiple volumes attached to it, and then we're going to replicate between those different volumes. So in the cloud, say Sandless, on the back end, those EBS, volumes might very well be backed by a SAN, but the concept of Sandless is really more than that the data is not shared. So a traditional cluster would have data on a SAN, so either fiber channel SAN, iSCSI SAN, and there'd be one LUN, and depending upon which node was active, that node would have control of that LUN through SCSI reservations. So there's only ever one copy of the data. And I know some people will argue with me if I say, the SAN is a single point of failure. I say, well, that's not true, Dave. There's multiple, controllers and RAID and power and all that. And sure, and you can spend hundreds of thousands of dollars on a very high-end SAN and have all the redundant switches and everything you need to eliminate any single point of failure. But at the end of the day, it is still a single box, and there's certainly, customers come to me, on a regular basis have had SAN allergies, and now they're looking to move away from a SAN and have, multiple copies of their data in different storage tiers. So they might still be using a SAN on the back end, so that the volume might be attached to a SAN, but then they're replicating to an entirely different SAN, maybe in a different building, and it gives them, even a higher level of availability.
Okay. The next question is related to just clustering in the cloud. Are there any native ways of doing this? Does Microsoft even allow you to do anything like this, or is it really the SIOS solution really does help with that, cross availability zones and so forth?
Sure. So we're talking about infrastructure as a service, and you're building out your own SQL Server deployments. Then you have to account for availability, and so really there's two ways to do that. There's the always-on availability groups, which doesn't require a shared storage device, or the SIOS Sandless solution. Now, if we're talking about, we mentioned platform as a service. Now, SQL, Azure, and the Amazon RDS solutions, they have they serve up, databases as a service, and yes, you can build your applications on top of those database services. And again, talking about platform as a service, one of the benefits of platform as a service is that you do not have to control the underlying infrastructure. And so Amazon and Microsoft will give you high availability options that you can turn on or turn off. So the benefit is that you don't have to manage that, but then that's also kind of the downside, is that you're kind of limited. You really have to, if you're considering using platform as a service, you have to really read the fine details, because not every feature is supported. Sometimes it doesn't scale as well as you might want it to scale. So platform as a service certainly has its use cases, but I would say it's really for smaller new deployments that don't require all the bells and whistles of using a full SQL Server implementation that you manage at the at that bottom layer.
Okay. The next question is related to Azure, and somebody want to know, can they use Azure as a cloud platform?
Yeah, Azure, and I mentioned early on that I wrote a blog article that Microsoft Press picked up and published that kind of describes Azure and deploying clusters in Azure. And I think each cloud provider, there might be a little wrinkle for each cloud provider and some different gotchas you need to be aware of. And Azure specifically has some requirements in terms of client access point and how you actually connect to the cluster. It has to be connected through a load balancer from a different cloud service. And so definitely do your research, read about Azure, deploying Azure clusters, and it's actually getting better. So be on the lookout for some new articles coming out soon. Azure's got a new technology called internal load balancer, which is going to make the client access a lot easier. And so keep your eyes open for that. There'll be some more information that should be published pretty soon.
Okay. There's a few questions about pricing, so if you can just let people know who to contact or how to contact or where to look for pricing information.
Yeah, absolutely. If you send an email to info@us.sios.com or give us a call at the phone number there, 650-645-7000. Just want to have a quick conversation to make sure that we're getting you the right solution for your environment. We'd be glad to speak with you.
Okay. Next question is related to SIOS working with Microsoft and support and collaboration, and how does that all work out?
Yeah, absolutely. So SIOS is a gold certified partner, and the Datakeeper Cluster Edition is logo certified from Windows 2008 through 2012 R2, and they're very aware of our solution, and they're happy to have their customers use our solution. The support line, you really think of our solution as your data tier, right? Your storage. So if you build a traditional cluster and you had a problem with clustering, you would call Microsoft. And if the problem turned out to be that your storage was misconfigured or wasn't behaving properly, then Microsoft would have you call your storage vendor. So then you pick up the phone, you call your HP or EMC or Dell, whoever, and work with their storage specialist. And it's very much like that as well. We only have one level of support. It's enterprise level support. So it's 24/7, 365 days a year, where if you have a problem and you think it's related to the storage or replication, then you can certainly call us, and we'd be glad to get on the phone and help diagnose the solution. And many times it turns out it's not really even related to us, but we're so tied to the clustering, we get pulled into a lot of scenarios that maybe shouldn't have been our call in the first place. But we're glad to help out where we can if it's an obvious problem with clustering that we can help you with. So it's really two-way. So Microsoft will certainly support the solution, and if it turns out that it's related to the storage or the replication, then we'll work with Microsoft to come to a resolution.
Okay, great. All right, the next question is related to other uses. So can you use this beyond the database tier for application servers, web servers?
Yeah, so the underlying technology is a replication engine called DataKeeper, and it does block level volume replication. So any data that's written to a volume can be replicated from one server to another. Now, we don't replicate the entire system drive, so you wouldn't install it and say, we'll replicate the C drive from this server to another and think that you're going to be able to replicate just the entire instance. However, if this were a Hyper-V virtual machine, then you could replicate the entire virtual machine. So you could install on the host operating system, the Windows operating system, and if you're running a Hyper-V cluster, you can build Sandless Hyper-V clusters as well. So you can fail virtual machines from one physical server to another without a SAN, just as you would if you were deployed on the SAN.
Okay. All right, the next question is related to performance. It's just, I guess, just more general clustering, or excuse me, cloud type of question. And just wondering, would the cloud give it better performance for SQL Server? Is that possible to get more performance out of a cloud implementation versus an on-premise?
You're really limited in terms of what the cloud provider is offering. So as the cloud becomes more mature, you're seeing larger cloud instances, so more CPU, more RAM, and better storage options. So in most of the clouds today, it really depends on how much money you want to spend. So if you can get dedicated, if you really want, you can have physical servers dedicated just for your instance. You can have SSD type storage dedicated just for your instance. So the more money that you want to spend, the better performance you're going to get out of the cloud. So you have to kind of weigh your options, in terms of performance. And Amazon, like EBS, block storage, there's lots of articles in terms of tips and tuning your storage for optimal IOPS. So, you could go out and buy today some physical servers and put some, PCIe flash storage, and it's going to be hard to match, but you can go and lease those servers in a cloud-like environment, but it's really, at the end of the day, you're just leasing the same server you would build in your data center, and you're just going to spend a lot more per month on that server that'll be dedicated to you versus sharing it in a multi-tenant environment. So the answer to your question is, yeah, it's possible in the cloud to have just as high performance as you do on-premise, but generally, you're looking at saving money and easing in and having rapid, scalability. So, one of the use cases you hear about clouds all the time, where you do most of you're a retailer and you do most of your business in the 6 weeks leading up to Christmas. So you don't need a whole bunch of bandwidth and a whole bunch of CPU and storage and memory for 11 months out of the year, but for 1 month out of the year, you need to quadruple your capacity to handle the load, and the cloud is great for that. So you can turn down all your services 11 months out of the year, and then when you're ramping up for the big holiday rush, you can scale it out, and so you only have to pay for those resources just for the time that you need them. So that's really one of the key benefits of cloud services, is that rapid elasticity.
Okay. The next question is just related to the type of virtual environment supported? And I'm not sure this related to the cloud or to the SIOS solution, or maybe both. We can talk about which virtual.
Yeah, the software runs on Windows operating system, and the underlying hypervisor platform is irrelevant. So it supports any hypervisor platform where you can deploy a Windows virtual machine, and that's to build, your SQL Server Sandless clusters. If you are looking more at I was mentioning earlier, if you're trying to build a host-based cluster where you're clustering entire virtual machines, then you are limited to Hyper-V only because, Hyper-V runs on a Windows platform, and our software runs on a Windows platform. So you can install our software on the Windows host Hyper-V server and then replicate those VHD files and do that. And you couldn't do that with a VMware. We can't install DataKeeper in the VMware kernel and do that. So for host-based replication and solution, it has to be a Hyper-V.
Okay. The next question is related to the data replication, and they were just wondering, will SIOS support replicating data to different geographic locations, such as the United States and somewhere in Asia?
Yeah. So the replication engine supports, one-to-many or many-to-one type replication. So you can have multiple targets, and it runs either synchronously or asynchronously. So for well-connected networks, meaning when we're talking about clouds, they would be nodes within the same geographic region. So between availability zones, you might do synchronous replication, and that guarantees the data is always 100% in sync and, allows for automatic failover with no data loss. Now, if you're extending that, so you might build out your cluster in the Amazon East between two different availability zones, but you're looking for a little bit more protection in the event that, the entire East region of EC2 becomes unavailable. You can also dedicate a target in a different region, so Asia or West Coast or whatever. And then when you're replicating further distances, then you're going to choose asynchronous replication, which is near real-time replication. The difference is that with synchronous replication, the write actually has to commit on the target system, and the target sends an acknowledgement to the source before it's written on the source. So that's what guarantees the data is always 100% in sync. But if you try to do synchronous across long distances, the time that it takes to send the data and receive the acknowledgement and with the latency on the link, it's going to impact your throughput. So your performance is going to suffer. So to get over that is we choose asynchronous replication, where we don't hold up the initial write. The initial write can go right to the disk, and then we send those writes as quickly as possible, and we keep track of all the writes that have not been committed on the target yet in a bitmap file, so that we can keep in sync very fast without impacting the write throughput. But there's always a chance that in an unexpected failure, where someone comes and pulls a power cord on the source, then not every single write had made it from that source to the target. So, we're not talking about minutes or hours of data loss. You might be talking about a few writes of data loss. And you can track how much data is in the async queue through a performance counter called queue current length. It'll show you at any time how much data is in that async queue that would be lost in the event of an unexpected failure.
Okay. The next question, Dave, is related to replication across different versions. So I'm assuming SQL Server. Is that possible?
Well, we replicate at the block level, so we really want to see what the data is, and so we don't care, different versions. But Microsoft certainly has some restrictions. If you're building a SQL Server cluster, then the data, the versions of SQL they have to be the same. So you're not going to replicate and build an automatic failover cluster between SQL 2012 and SQL 2014. So for clusters, the versions need to match. But that's really more of a Microsoft restriction than a DataKeeper restriction.
All right, let me take a look at some other questions here. All right, another question is about latency with failover to cloud versus, I guess, failing over locally. So any thoughts or suggestions on that as far as the time it takes?
Yeah, I mean, the actual failover time is the same. So, the amount of time it takes to move from one node to another is dependent upon, how long it takes for SQL Server to start, the services to start. So, larger databases or very active databases might have to, an unexpected failure, might have to rewind some uncommitted transactions and, before it comes online. So you have that, but that's the same as whether it's on-prem or off-prem. The biggest difference would be, whether or not you're failing across subnets. So you have to account for client redirection. On-premise, generally you're in the same subnet, and so you can protect an IP address, and your applications are configured to speak to that virtual name, which is tied to that virtual IP address. So client redirection is pretty instantaneous. In the cloud, it depends on your cloud. So in Amazon, between different availability zones, it's different subnets. In Azure, different fault domains can actually be in the same subnet. So in some cases, some circumstances, the Azure environment is going to have a faster reconnect time for your applications because you can your IP address is not changing. Anytime you're failing across subnets, there's lots of different ways for your clients to reconnect, but you might have to wait for your IP address to refresh. You might have to wait for the TTL to expire on the DNS name before your application will get the new IP address and reconnect to the cluster coming online. And again, that's the same as on-premise if you're failing between different subnets as well.
All right, the next question is related to clustering virtualized SQL servers, and just wondering, are there any issues or any gotchas that people need to be aware of when they're clustering VMs for SQL Server?
No, I mean, virtual and physical are the same, and one of the big use cases we're starting to see pop up more and more often are people that not necessarily using cloud, but people using VMware in large deployments of VMware, where they realize that VMware HA is really not the end-all, be-all of high availability. It protects them from system level, hardware level failure, so that if one host fails, another host can recover that VM. But of course, it has to recover from a cold state, so it's booting that VM back up. And so that failover time, we're talking 2 to 3 minutes, which does not always meet SLAs. And so they said, well, we need to cluster at the application layer. So you read the white papers, you say, oh, we got to do raw device mapping, and so that these virtual machines can share the same disk. So they went down that route, and then they realized, like, wow, we gave up by doing this. We've given up a lot of the functionality of virtual machines. We can no longer do live migrations and doing snapshots and all that is not supported. So now we have people coming to us who have built SQL Server clusters, traditional shared storage clusters in VMs using RDM, and they're looking to get away from that. And by using our solution, they can have traditional failover clusters, but each virtual machine would have its own additional VMDK file attached to it, and we're replicating between the VMDK files. because we're no longer using raw device mapping, they then gain all the functionality that they had to give up with raw device mapping. So they had to, they can now do live migrations and all the other features that they gave up using RDM. So it's actually a better solution than traditional shared storage cluster in that virtual environment.
All right. All right. Well, thanks, Dave. Actually, we're out of time, so we're going to wrap things up. There are a few other questions we didn't get to. What I'll do is I'll send those over to Dave, and as he has time, he can get back to people to answer some of your questions. But I also want to thank SIOS for sponsoring today's event. So after today's webcast, please visit their website at us.sios.com to learn about all their offerings for SQL Server HA solutions. This webcast was recorded, and you'll receive a follow-up email with the links to view the archive. I'll also get a copy of the slides from Dave that you can download as well. Also, please visit mssqltips.com to access all of our free SQL Server resources. I want to thank everybody for attending today. And when you exit the webcast, if you just take a few minutes to fill out the survey, it helps with today's webcast as well as future webcasts. Thanks again for attending, and hope you all have a great day.
Great, thanks.